So we're going to get started. So we're Inco, what we call the Universal Confidential Computing Network. Today, all the layer 1 and layer 2s have one thing in common, is that they're all transparent. Now, we believe that in order to get mass adoption, we actually need a minimum of confidentiality. So just a couple examples. When you use crypto today as your bank account, everyone knows exactly how much money you have, especially when you use for payroll. All the employees within a company also knows how much they're making. And this is a known bad practice we have already in Web 2. Second, enterprises and institutions are still having a hard time entering the space. They have compliance reasons. They also have trade secrets. It just doesn't make sense for them to build on top of a transparent database. And lastly, there are just a lot of use cases that wouldn't make sense without any hidden information. So think of the card games, private voting, or blind auctions. A lot of folks today focus on solving the throughput problem or the cost problem of blockchains. We believe that there's a lot of new use cases that can be unlocked with just confidentiality alone. So this is what we call the public and private blockchain use cases. And to do this, we leverage a cryptography called fully homomorphic encryption. So maybe by show of hand, who has heard of this term or knows what this is? Okay, about half of the people here. So it's very different from ZK. What FHE does is one thing, and one thing really well, which is computation on top of encrypted data. So imagine if you were to encrypt some integers, you can still add, divide, multiply on top of it without having to decrypt. So this is really the magic of FHE. For folks who are non-technical, in case you're non-technical, imagine you can encrypt this cat picture. You can still modify each pixels by adding, dividing, multiplying, and by the time you decrypt, now you have a filter, right? So this is almost sounds like magic. It's really a cryptography that allows you to compute on top of hidden data. Now, why is this interesting in the crypto space? So, typical legacy privacy solutions that we think about, in crypto is typically ZK. What makes FHE really stand out is the composability aspect. So why does composability matter in crypto? Blockchains are multiplayer systems. If you want to build DeFi or gaming, you need to be able to interact with each other's private state. And so with FHE, you can store the encrypted data on-chain, but you can directly compute on top of it. So the blockchain itself is the shared private layer. What happens with ZK is oftentimes you have to store these private data off-chain. And so if everyone's storing their private data off-chain, there's no composability, unless you have a centralized prover that can coordinate the states. So when you apply FHE into an EVM called FHE EVM, it's very straightforward. So you have your typical Solidity. All you have is an encrypted type called EUINT. So in the first line of code here, just an example, this is an ERC20. You have a mapping of address to EUINT, so you can have a hidden balance. And when you do an ERC20 transfer, what you do is you add an encrypted amount to someone's encrypted balance. So it's very straightforward. You do a tfhe.add and tfhe.sub. It just reads and writes like Solidity. And then lastly, we also offer on-chain randomness that are quite useful for card games, any hidden information games. So what are some of the benefits? So for one, it doesn't require any hardware secure enclaves, TEs. It doesn't require you to learn any complex languages, how to write circuits. Also, it doesn't require any centralized off-chain coordination that a lot of the ZK-based solutions require. And so let's talk about use cases, right? Like, what can you build with this? So if we take a step back, a lot of people think what we do is privacy, but privacy is really just a subset of things you can build with confidentiality. So let's take gaming, for example. Today, all the crypto games are not as challenging because everything is transparent and public. So if everyone has perfect information, there's no fun. A lot of the fun games that we have in Web 2 requires some hidden information. So think of the card games like poker, some of the bluffing games, things that you have to guess if the enemy is more powerful or less powerful, right? All that requires a minimum of confidentiality. Else, there's basically no fun, no challenge, right? Second, in terms of DeFi, there are just a lot of new primitives that you can think of. So you can build dark pools, blind auctions, private AMMs. You can even think of novel primitives around under collateralized lending, just because you can hide certain information. On the enterprise, I mentioned payroll earlier. So payroll is a very obvious thing you could build. You can just hide the amount that you pay your employees in a very simple manner. You can also do private cap tables, treasury, or even predictions, right? So imagine if we all submit the hidden price of Bitcoin, we can still calculate the average price without having to decrypt using FHE. So last year, we actually built a fully on-chain mafia game using Inco. So in this game, you could be a doctor, killer, or detective. It's a bluffing game. And it's very simple. You generate the role on-chain. And so the role here within the struct is just an EU into 8. So very straightforward, right? So if you're 0, you could be the killer. If you're 1, you could be the doctor. If you're 2, you could be the detective. We also bring confidentiality to existing blockchains. So this is where, if you want to build, let's say, a poker game on Base, what you could do is you can build the game logic on Base where you can raise, you can fold, you can call. Just use Inco as the layer to generate and hide the cards. So the idea is this: we want to meet builders, halfway. Like, what if you want to build on existing chains that has existing liquidity or user base? You don't have to build on Inco. This is where you can use Inco for specific features. Another example is, imagine if you were to build some kind of RPG game on Ethereum. What if you just handle the battle mechanics on Inco? So you can trigger the battle on Ethereum. You can have all the player stats that are hidden, right? Your attack power, defense, speed. All these stats could be hidden to add additional fun. And then using the on-chain randomness, you can also use that as a multipliers, right? So this is actually just a really good example of how you can re-transform a game by adding layers of complexity that just does not exist today in crypto. This is particularly an interesting use case that's also quite novel. So today, when we think of DIDs, they're basically soulbound tokens. So on the right side, you can see, typically what you do is you KYC with someone like Binance. They would, take a look at your identity and then issue you a soulbound token that says, are you over 18? Are you based in Europe? Is your credit score over 700? It's quite inconvenient because this is static. Like, what if this information changes over time? Also, everything is public. What if you don't want to reveal everything? So this is a concept that we came up with called dynamic DID. The idea is, what if you can store someone's credit score in an encrypted manner directly on chain, or someone's age, right? Your age could just be your date of birth, converted into timestamp, but encrypted. So you store this on chain, and then you can expose specific functions, view functions, for creating insights. So just quickly, the way this looks is very straightforward. What you do with FHE is not only operations, you can also do comparisons. So imagine if you were to do a comparison of the hidden credit score with 700. What you get in return is encrypted Boolean that you can decrypt. And so basically, you can reveal insights without revealing the actual information. So now back to this, right? Imagine if you have specific information stored on chain, just specific queries, right? View functions that maybe for Casino Dab, I just want you to know I'm over 18. I don't want you to know that, what my credit score is, right? So it's almost like selectively revealing information that makes sense. And so if you think about this, this is actually the Web2 experience that we already have today with Google Auth. If you're using Google Auth and you connect to, let's say, an application, you can give them access to your calendar, maybe your contact, but maybe now your Google Drive, right? So this is an interesting, I would say, use case as well, where over time you could update someone's credit score that can change over time, and then the insight can change in a dynamic manner, right? So just as an example, imagine you have, let's say, a money market on Polygon, and you just want to whitelist users who have a good credit score. So what you could do is you could ping this DID layer that returns you the specific insights, and then you can whitelist the user. So we are compatible with existing Ethereum tooling. This is why folks have been having a lot easier time getting started. Just use Solidity, MetaMask, Hard Hat Remix, things that you're already familiar with. We support a fairly wide range of operations today, so from additions, divisions, multiplications, but also a lot of comparisons. So it's really up to you to unleash your creativity, think about novel experiences and dApps that you can build. So maybe for a private AMM, you need to use some multiplication, divisions. Maybe for the DID layer, you need to do comparisons, right? So because of this wider range of support, you can recreate a lot of the logics that you have in games and DeFi. And just to take a pause, basically, if you think about what we do here, is recreating the concept of almost like this private state that we have in Web 2. In Web 2, if you were to build something like eBay, you will have a centralized server, everyone submits their bid. The server is not going to reveal everyone's bid, right? Because everyone has to bid secretly. Now in crypto, because everything's transparent, you can't have that experience. So the only way to protect information is through encryption. So there's no private state in blockchain, it's basically encrypted state. Now with FHE, because you can compute on top of these encrypted states, you get to build more complex logic that basically you would normally do in Web 2 with this centralized server idea, right? So a lot of the things that you see here is basically interesting in a way that you can bring in a lot of the Web 2 experiences, the use cases, to Web 3 using these operations. So to get started, all you have to do is import this library. So it's a FHE library. If you are familiar with Remix, the simplest way to get started is to use Inco's Remix. Pretty straightforward. Our current version does have a little bit of a version issue, so you have to use 0.8.20 for now. But yeah. One more thing here is when you build using confidential information, one thing you have to understand that there's no if-else statements. The reason why is imagine if you were to execute if-else statements on some kind of logic, that path would actually reveal what the hidden information was, right? So the way to go around this is this multiplexer function called CMUX. So here's just a very simple example of a private voting. When you cast a encrypted choice, which could be 0 or 1, the first thing you do is you compare if this encrypted choice is equal to 1. So you get an EBOL, which is an encrypted Boolean. What you do is you pass in this encrypted choice into a CMUX, which is a multiplexer. So if you're familiar with things like JavaScript, a CMUX is basically like a ternary function. It returns the first argument if it's true, second argument if it's false. So in this case, if the choice was equal to 1, you will return the encrypted vote count. If it's false, it will return 0, but 0 is also encrypted. Now on this third line, it's the reverse. You return 0 if it's true, and then encrypted vote count if it's false. So one of these two arguments would be 0, and then the other one would be the actual vote count. And you add both of them to their respective tally. So this is how you can go around this if-else problem in encrypted values, is using CMUX, essentially. There are two forms of decryptions. So this is quite important. So the first decryption, TFHE.decrypt, would decrypt and reveal the plaintext to an entire network. So this only makes sense if you want to reveal something and not be afraid that this information would cause consequences. So for example, in a poker game, at the end of the round, when you want to reveal everyone's hand, you want to use TFHE.decrypt, right? Now the second function is a re-encrypt. So what is a re-encrypt? Re-encrypt allows you to query your own, let's say your own balance, in a way that doesn't leak information. So the way this works in practice is, on the client side, you generate a temporary private key that goes with a temporary public key. And then when you pass into the view function, you pass in this public key so that when the MPC network decrypts, it will do partial decryption and re-encrypt that value using your public key. And so all these values will be sent back to your browser. And using that temporary private key, when you decrypt, you can reconstruct the plaintext. So this is a way so that only you can see the hidden information and not anyone else, right? So this is good for, let's say, in poker, if you want to look at your hands without revealing to everyone else. Or let's say for an ERC20 balance, you just want to view your balance. This is also a great way to use this function. One more thing, as you can see, there's a signature. A signature here is just an EIP 712. It's just to prove that you are you. So not someone else is trying to decrypt your balance, basically. So let's go over some of the tooling here. So there is a JavaScript tooling called fhEVM.js. So what you see here, this is called a ciphertext. A ciphertext is the way you hide data in FHE. It's composed of the actual data with some noise padding, and some data padding. So let's say you want to transfer 10 tokens, right, in a confidential manner. What you do is you encrypt the integer 10 using this library. And then when you pass in to the Solidity contract, you pass in as a call data in the form of bytes. You have to cast this into a EUINT8. So if you see below here with the hidden score example, so you have to pass in as a bytes data, and then cast that into a EUINT8 type. And so today we support EUINT8, 1632, and EBOL, and we'll support 64 and 128 very shortly, including e-address. So yeah. So let's talk about the bounties. So we have 10K in bounties. There are two tracks. One is gaming. The other one is open innovation. So we've hosted about 4 hackathons already. And I would say gaming has been one of the more popular tracks for most people, because for one, it's easier to build. If you can think of some kind of mini games, hidden logic, you can easily recreate this within 24 hours. It's also typically more fun to build. DeFi, there are definitely a lot of interesting things you could build. It's a little bit harder. Just to give you an example, if you build something like a private AMM, some of the concepts you might have to think about is around differential privacy. So let me give you an example. Imagine you want to do a confidential swap. If someone swaps before you, and then you swap, and that person swaps right after you, technically that person can guess how much you have swapped out, right? But there are ways you could, there are techniques you could do to basically prevent information leakage, including differential privacy. But typically these topics are a little bit more complex, but nonetheless, I think there are quite a bit of interesting things you can also explore. And then in terms of infra, you can also think of that DID layer example that I gave earlier. You can combine that with the money market. So imagine you have a money market that only lends out if you have a good credit score, right? So this is where there are rooms for sort of novel primitives, ways that you can think about composing different DeFi primitives, including gaming. And then we also have a list of ideas here on this Notion page. So yeah, if you are short of ideas, feel free to check out this page. We also have a booth there with all our team members. So we're always happy to provide feedback. Come talk to us. We're very passionate about exploring novel ideas. You can also join our Discord. So we have a dev chat here for any technical support. And Telegram group. So we do have a testnet. So yeah, feel free to get some testnet tokens and then get started. Yeah, just leave it for a second for people, take pictures. And then lastly, yes, we have our documentation here. There is an arcade page with a few demos. So some of them include simple mini games like the Mafia game, Wordle, simple hangman, slot machine. So just for people to try out the novel experiences that Inco can offer. And that's it. Thank you.